Okay, so what I want to talk about today is secrets in the cloud with Vault. And there's some exciting things to talk about there. Before I get started, I just want to thank all of you for coming, thank Octo for hosting, and thanks for organizing and things like that. It's awesome to see this many people. It's my first hug that I've been to in Paris, so it's very cool to be here. But what I want to talk about is Vault, and also something very exciting, kind of a coincidence, is that Vault 0.10 came out yesterday. So this is a super exciting release, and I'm going to talk about Vault 0.10 today, as well as use some of those features of Vault 0.10 in the normal top of the talk that I have, and use it for a lot of the demo type stuff. So we'll talk about both. I imagine here is familiar with HashiCorp to some extent. So for those who don't know, there's other things we do too. A lot of people know, one or two or three. These are sort of the 6 major projects we have. These are all open source. They're all free. 4 of them have an enterprise component that we sell to make money. But today I'm just going to be talking about Vault. I'm not going to be touching on any of the others. But if during the Q&A you want to ask me about any of the others, that's okay too. So feel free to ask me about anything. And if you don't want to ask in the Q&A and you just want to talk to me later, that's also okay. So in a couple months, we're going to have Hashi Days in Amsterdam. So we've conference sort of in Europe for the past few years, and here we are doing Hashi Days in Amsterdam. It's going to be really exciting. We are going to announce some things, and we're getting a lot of people together in the region. So please come, please check it out. We're also giving away 1 ticket today, so that's what you filled in there. So if your name gets drawn, please come. So to get started, I want to just sort of start by talking about what Vault is. This is not an introduction to Vault talk. I'm not going to go over all the features and why you have them and how they work, but I will give an overview. This will be a specific how you use Vault in a certain way kind of talk, but I do want us all on some basic same level of understanding. So I'm going to do 3 or 4 slides on the overview of Vault, and then we're going to dive into some stuff. So Vault is sort of mostly a secrets management solution. It's concerned with how to store, protect, create policy around secrets, and that's it in the most general form. And when I talk about secrets, I mean obvious things like database passwords and API tokens and things like that, but I also mean encryption keys for PII data, TLS certificates, and various other things. Basically anything that you don't want people, anything you wouldn't feel comfortable the public knowing about is stuff that Vault wants to help with. And to achieve this, there's a number of features, and this is the overview of the major sort of fundamental features of Vault. And so this slide actually hasn't changed in content since Vault 0.1. Like when Vault first came out, I think 3 years ago, this was still the same content because these are the important base features that Vault provides, and everything we've done since then, we've shipped a lot of releases and a lot of features. Everything is built on top of this, but these are sort of what we believe that you need to look for in a security product. So starting at the top here, just to give an overview, Vault, of course, has to securely store things. That's a given. So Vault is a security product. Everything Vault stores is encrypted both in transit and at rest. It's encrypted using sort of the algorithms and key sizes and things like that that you would expect of a modern tool. We threat model online, so we're very clear about what we protect against and what we do not protect against, which is very important for safely deploying something. And we also support storing the data in a bunch of different locations. So we could just keep it in memory. We could put it into console, which is another one of our tools. You could put it on a file, a database, and so on. And one of the nice things about that is that if your company is an expert with console already or an expert with Postgres or something, you could use that as the data storage. So the backup story and things like that is what you should operationally be experts at. And Vault is designed to not trust the data storage engine. So all the data in there is always encrypted. It could detect tampering of the data, but you could sort of back up that data however you like. It's not a risk for that data to be accessed, although you don't want it to be accessed. An important part of that secure secret storage is sort of solving how you get the way to decrypt that data that's in the backend store. And so the way you decrypt the data with Vault is you provide a number of keys online to decrypt that data, and we call this the unseal process. So when Vault starts up, we use an algorithm called Shamir's secret sharing to split a key into n number of pieces, and the right number of people have to put their keys together in order to start Vault up. But once it's started, it'll keep going forever. And we do a bunch of other stuff to try to protect the key. So that key actually is thrown away almost immediately. It's called the master key. We create the master key. The master key is used to decrypt a handful of other data keys. We throw the master key away, and the data keys are what actually protects the data. So building on the secret storage, we have this concept of dynamic secrets. Dynamic secrets represent sort of the ideal scenario in the future that you want to achieve everywhere, but it's hard to do that. So beyond static secrets, dynamic secrets generate a secret only for the duration that you need it, and it's brand new each time. So an example here are database passwords. Historically, what you would do is you would have a number of applications, let's say 50. All 50 of those applications would be given the same database credential through some mechanism, config file, environmental variable, somehow it gets there. And then that's it, right? With Vault, what you do instead is you give a super user to Vault, and then every time an application asks Vault for a database, Vault creates a new database user when they ask, gives it to them, assigns a lease to it, so it says this database user is good for the next 30 minutes, and that application checks in. So every 30 minutes it says I'm still using this, so it's okay. But if you violate the lease, if you don't renew the lease, then Vault drops the user and drops all the connections for that user. So the credential is very short-lived, and the shorter the lease period, the better, but you could specify weeks of lease. But the shorter it is, the better, because that forces the application to come back and check in with Vault. And when that check-in happens, we audit it. So anytime anybody ever talks to Vault, we put it into an audit log. You could have more than one audit log, which is a good protection against tampering. A lot of companies in production will send the audit log to something like Splunk, but also send it to something like syslog. That's not going to Splunk. And when there's a breach or you need to investigate something, you can look at both, because if they differ, then you know that also the audits are probably tampered with. So it gives you a hint of what's sort of going on. On top of all of that, there's rich ACLs. That's sort of another obvious one. You need to protect the data and on top of encrypting it. So the rich ACLs let you say who can read, who can write. And the ACL capabilities of Vault range from sort of basic, for this key you could read, you could write, you could delete, to extremely, incredibly advanced. You could program the policies to be dynamic, basically. You're executing code on every request to do more complex things, like you could only access this key between 10 a.m. and 5 p.m. or things like that. It could get incredibly complex, but you could start very simple. So it has all of that built in. And then finally, this is sort of what I'm going to be talking about today a little bit. It has multiple ways to authenticate with Vault. And I'm going to talk about that later, so I'm just going to leave it at that, and we'll get there. And so all these provide the base sort of required features for Vault. And on top of that, you know, Vault is like a Swiss Army knife. You could do a lot of stuff with Vault, but the three major things that we see people do are these use cases. There's centralized secrets management. I don't think that needs any explanation. That's quite obvious. There's identity and access management. So Vault has a whole set of features around obviously creating credentials, but reasoning about what a credential, who a credential is, I guess would be the way to say it. Because we live in a world where there's a lot of physical credentials that map to one logical being. So a good example is that me as an individual at HashiCorp, I have some AWS access keys for some parts of our infrastructure. I have a GitHub token to access our organization. I have a Slack token to play around with Slack. And I have a bunch of other things that are secret. We definitely don't want the public to know about that. We don't even want people in HashiCorp to know those about me. But if you look at that in a log, it's just a UUID or a token or something opaque. What you could do with Vault is actually say that that AWS credential, that Slack token, that GitHub token, that is Mitchell, right? Logically, that's Mitchell. And then you could put that into groups and say Mitchell is part of the executive team, or however you want to group things together, or as part of the console team, or whatever. And that way you could search and filter and audit based on the logical entities, which is much simpler to reason about versus the physical ones. And also from a revocation standpoint, if I'm compromised as an individual, you could say revoke all secrets that Mitchell has created, right? And that'll, all the ways I've authenticated with Vault, it'll pull everything out. And then finally, there's the encryption as a service mechanism. So Vault has the ability not just to store data securely, but to encrypt data that is stored elsewhere. So with this, there's a couple modes. There's one where you just send plain text data to Vault, say an address or a phone number, and Vault returns the encrypted data. This is great for developers because developers don't have to deal with keys. They don't have to pick how it's encrypted. They don't have to rotate the keys ever. They just ask Vault to encrypt something and it comes back. So this is a really awesome way to do things like PII. In Europe right now, there's a really popular thing, popular positively and negatively, called GDPR. Encryption as a service helps really greatly with GDPR. So you're actually able to, when you encrypt something, you could give Vault what we call a context. That's very often something like a user ID. The context is actually used to derive a new encryption key that's unique to that context. And so for right to forget for GDPR and stuff, if you encrypt all of a user's data through Vault with their user ID, when they say forget me, you could tell Vault to delete the key associated with that context, and all their data is gone, right? It's unencryptable forever. So that's a really easy way to do that, right to forget with Vault. Okay. On top of that, how do you run Vault? These are all really awesome features, but if it requires like 50 machines and something crazy, it's not super fun. But Vault is relatively simple, right? It's a single binary. We write it in Go. The binary is both the client and the server and all features associated with it. So you start it. It runs on commodity hardware. We don't have any specific hardware requirements for Vault, although certain versions of Vault, particularly the enterprise versions, do integrate with specialized security hardware, should you need it. For high availability, we sort of built Vault to expect failure on the machines. We don't tell you that if Vault goes down, you're in a lot of trouble. We tell you that Vault can go down and it'll recover, and the way we do that is with a leader standby model. It's not sort of replicating data anywhere. It's just there's one leader and there's a number of standbys waiting to take over, and when a leader goes down, another one gets promoted. So if you put a load balancer in front of Vault with the right health check, then you could get high availability. And then finally, there's a lot of multi-cluster replication stuff for geographical replication and so on. That's in Vault Enterprise, and I'll mention that in a few other places because it's important for understanding sort of reference architectures. But the core of this talk, I mean, all of this talk, 95% of this talk is all going to just all be open source features. Everything I mentioned prior to this is all open source, all free. I want you to be able to take away something that you could use. And Vault doesn't limit you on secrets or connections or anything crazy like that. You could completely build a fully functional system just with the free and open source. It's not limited in that way. And then Vault 0.10 came out. So yesterday it came out, and it's a very big release and a very exciting release for a few different reasons. So I'm going to talk about the features that are in Vault 0.10 for those who are already Vault users, and I'm going to show some of them as part of the multi-cloud secrets thing. So the first one, which I think is the most exciting, and judging by the reaction of the release is probably the most exciting, is that we open sourced our UI. So for about 18 months in the enterprise version of Vault, we had a UI. And we've built sort of enough other enterprise features that we felt that we could open source this. So the UI is both open source and both built into the to binary by default, which you'll see. Because the UI has been around for 18 months, it's actually quite mature. You don't log into a UI that's lacking a lot of features. You log into a UI that large companies have been using for over a year. So it could do quite a bit, and there's a lot of first-class workflows for things like generating certificates or encrypting or securely linking data from one person to another. There's a lot of neat things in there built on top of Vault's features, and there's a lot more coming. So there's a lot the UI definitely can't do. Vault has a very large set of features, but the team every release is going to have more and more UI features. Vault 0.10 has versioned KV. So for the static secret store where you just give it a key and a value or a set of keys and a set of values, that used to just be, when you wrote something, it overwrote it. And now it's all versioned. So you could actually write a key multiple times and keep a number of versions in history. You could keep every version if you want, but by default it's a circular buffer. You could access past versions, you could delete versions, and you could undelete versions. I'm going to show you what that is and sort of why you'd want to do that. And it's mostly API compliant with the previous one. So for clients that don't know about the versioning, you just get the latest version. But if you start building software that's aware of versioning, you could kind of do some neat things and control the upgrade path as secrets change. So to show you what that looks like, the Vault KV CLI already supports version secrets. So I'll show you an example here. In this case, we're writing a secret called hello and a key value that says target equals hug. You can see we get a bunch of metadata back, but the important one is that the version is version 1. We could read it back, and we obviously get version 1 back. That's obvious. I think all of this is kind of obvious. If we write again, and this time appending a 2, so same key on this too, but hug 2, we get a version 2 and obviously a new created time. And then if we read it, we get the latest version. So the default behavior is always latest version. I think that's expected. But then we could also start reading arbitrary versions. And the neat thing is that these versions are sort of part of the path and part of the things that an ACL could protect. So you're actually able to say in the policies that someone could access 3 versions back even if you're storing 10, or someone can only, you could do weird stuff like someone could only access every odd version back. I don't know. But that's all possible due to Vault's sort of powerful policy system. And then you could delete keys. So if you do delete, that'll delete the latest version. If we get the secret, you can see we get metadata back, and we had 2 versions. So we got version 2, but it now has a deletion time set against it, so it's deleted, and there's no value. So it does return some metadata, but this is sort of representing the absence of a value because it's not permanently deleted in this case. It's just sort of soft deleted. But at the same time, we can still get version 1. So version 1 wasn't deleted. Version 2 was deleted. You could then undelete that version and bring it back and then read it again. And so one of the benefits of undelete, it's sort of a weird feature, but the benefits of undelete is, again, the policy level thing. Undelete is at a different path. You could give different people the privilege to undelete. So you could say that the developer could always write and delete, but you never want them to permanently delete because for security or compliance reasons or whatever, you always want some security team to be able to read those values back and undelete them. And so that's a way to do that. But of course, I don't show the demo or show it in here because it's. But you could permanently delete things too if you have that permission. A couple more features. So Vault can now do database root credential rotation. And so what that means is I talked about the dynamic secrets and where Vault could give you a new database credential for every request. To do that, you have to initially configure Vault with a super user that could create those users. And from a security perspective, that means that there was a point of a risk, right? Which is the person who originally configured Vault with the super user had to see the super user's credentials. And so that person could potentially create unsafe users. And so now with the database backend, which supports every major SQL database and a lot of non-databases, when you configure Vault with the super user, what Vault immediately does is rotates that super user's password. So the moment you configure it, that super user is no longer valid. And this ensures only Vault knows about it. And Vault also doesn't have an API for reading that super user back out. It's just locked up in the Vault. There are some sort of break glass methods requiring the quorum of keys in order to get the super user back out, but it's not part of the sort of standard API set. And this starting with databases, which is a big target. I mean, we support a lot of databases, but we're going to keep expanding this root credential rotation to more and more features. So AWS, GCP for dynamic credentials, same thing. You could give it AWS an IAM credential to create users, and the first thing it'll do is rotate the keys on that user so no one else could create IAM credentials from that user. So this will keep sort of going around. And then finally, we integrated with, worked with Microsoft to integrate with Azure to do auth. I'm going to talk about this today, so I'm just going to leave this again. So that's Vault 0.10. That's a lot. All that stuff is open source. Like I said, it's a huge release. We tested it for a little over a month with both open source users and enterprise customers, and we feel good about all the features that we shipped, so feel free to try it. But now I want to move on to the main sort of topic here, which is secrets in the cloud. And what does this mean? I want to talk about how you sort of run Vault and access Vault from cloud systems, but also multi-cloud. And when I say multi-cloud, I also mean, hybrid cloud and including sort of, physical data centers, because it's sort of the same. But you have this problem. The problem that you're trying to solve is that you have secrets. You want to centralize your secrets, but you have multiple geographic regions or multiple cloud providers or this legacy physical data center that needs to access your secrets. And how do you actually do this securely? So I use the word cloud, and so it's worth talking about why I call out the cloud. What's so special about the cloud, and how does that affect security in a way that warrants talking about it? So the first thing about the cloud is that the cloud and then the trends that are closely correlated with cloud, like microservices and schedulers and platforms and all these various things that are not the same but very correlated when you adopt the cloud, all of them encourage a more dynamic, ephemeral type of workload. They encourage servers that only exist for the duration that they need to service something, or servers that come and go a lot, or applications that come and go a lot, or applications that can move at any given moment. It's all much more ephemeral than what we're used to over the past number of years, which is you start a server, the server lives for quite a long time, you put an application on it, that is that application's server, it's not going to move. It's different, and that has security implications that make things hard, because the sort of models of, for example, pre-authorizing or pre-authenticating a machine and an application on a machine for a certain set of privileges doesn't work anymore if the machine is disappearing or the application is moving, and now this server needs those privileges too. So it gets tricky. There's this cloud-specific identity concept. So this is mostly targeted at people with physical data centers. They have this nice ability to sort of assign an ID in a way that they're comfortable with, either by sort of security hardware or pre-inserting, a UUID, or using a MAC address or something to assign an identity to a machine, and again, sort of authenticate it that way. But in the cloud, you don't get a lot of the same things, but you do get identity, but it's all specific to a cloud platform. So AWS has IAM profiles. Azure has service principals that are part of Active Directory. Google has service accounts. There's all sorts of different cloud-specific identities that you want to be able to use for auth, but are different, so you have to build tooling around it, and Vault does that, so I'll show you that. There's no air-gapped machine access, so you could get close, right, using the VPCs and various things. You could get close to being able to access a machine without it feeling connected to the internet, but the fact is it's not the same as air-gapping something, and having an air-gapped machine is nice because you used to be able to take a server, and before it's ever connected to the internet, image it, set up its base security layer, things like that, then connect it, and have some base guarantee of security. But with most cloud machines, you're starting connected to some form of network no matter what. So that it complicates things as well. The last two are just things to think about. There's no clear network perimeter, so you can't just rely on physical walls anymore to protect certain things. You could try to create VPCs. I mean, you should create VPCs, but the truth about that is it's multi-tenant. It's all software. It's all SDN all the way down. Your bits are flying with other people's bits on the same network, and that can freak you out depending on what kind of company you are. And then the last one encourages more geographic diversity. It used to be really expensive, relatively, to create multiple regions and support multiple regions for your application. And today, it's pretty much accessible by anybody to spin up a few machines in a few regions and load balance between them and things like that. Whether that's the right sort of solution or not, people are doing it. and that has an implication on security because they both need secrets and they need to get them from somewhere, and you're either replicating secrets or you're talking across the global internet to grab secrets. So how do you get them? And so taking those special properties of the cloud and translating them to Vault, of why is this hard with Vault, or why does it seem hard with Vault? Actually, what I'm going to show you is it's not that hard. But why does it seem hard with Vault is that you have this first step of just deploying Vault securely. So how do you actually get Vault running in a way that is secure? Because if you start from an insecure place, there's some compromise that could have already happened. You also want so you just have that asterisk there, since although clouds are quite reliable today, you still sort of want them to support high availability. This is the major one. This second one is really where people get hung up on, and because security is just a tower of turtles, and every turtle you lift up when you're trying to figure out how to secure something leads to the next one. So just the classic thing with security, right, is, oh, I'll encrypt it. It's like, okay, I encrypted that, but where do I put the key? It's like, well, I'll encrypt that with this one, but it's like, okay, now where do I put that key? And it just keeps going pretty much forever. And so one of the issues is what we call secure introduction, is also called zero, is also called bootstrapping, which is when you launch a server, you want that server to get its secrets from Vault, but to get secrets from Vault, it has to have a Vault token, which itself is privileged. So how does it get its Vault token? And that's the bootstrapping problem. So this is the major one that we're going to talk about. And then the other two I spent quite a bit of time on, so ephemeral things and multi-cloud. And so then the answer behind this is actually that it's really simple. And so this is how you do it, but this is sort of like, I don't know if you've ever seen that internet picture of like drawing the owl, right? It's like, this is sort of like step one, draw a circle, step two, finish the owl, is sort of what's happening here. So one, you want to run Vault in a central place. You want to run Vault in one location, and we're going to talk about that. But once you have Vault up and running, the problem is step two, which is really where all the complexity, mental complexity seems to lie. The implementation complexity is quite low. So the mental complexity is, how do I actually get that token to happen? But once you have a Vault token, things are easy. Securing that token is not too difficult. You keep it in memory. You pass it on to other processes just purely through memory. Things like that is not as difficult, but getting that token is a challenge. So this is where we're going to spend most of our time talking today, because number one, we have a lot of guides for online. We're constantly publishing more guides of how to run Vault securely in different ways, and I'll link to some of those in here so you could have a starting point. But number one is more or less a solved problem with documentation. Number two is documented, but less talked about. So, and a problem that a lot of people hit. So that's what I'm going to focus on. So if we take this and then we show like an example diagram of what this might look like in an exaggerated way. So in a way that, you know, we're going to run on 4 different providers and just in 4 regions and really exaggerate a bit here. What you want to do is, let's imagine that we have a primary data center in EU West, and let's say that's on AWS, and you run Vault there. That's going to be your primary Vault data center region. And then you have 3 other regions: US East, China North, EU West, and then this EU West is like your legacy physical data center, so you have that too. You have these 3 things, and they want to authenticate with Vault and get a token so that they could get on their way. That's what you want. And let's dive into 2 of these things, which is the centralization and then the auth part. So first of all, it's centralized, and centralization is sort of a core philosophy of Vault, and it seems, to some people, it seems backwards at first, because the idea of putting all your secrets in one location is itself scary. But there's a few good reasons behind this. I'll start with the bottom, which is that it's much easier to secure one thing exceptionally well than it is to reproduce that exceptional security perfectly every single time. So you could, and in addition to that, you could dedicate a lot of resources to securing one thing really well in a way that would be too expensive to have that same level of security on everything. So an example of this, of our own larger Vault users, is that we have some folks that have crazy security policies that are deathly afraid of being breached at any given moment. And so they even go so far as to have full-time teams that all they do is watch and read every single audit log entry on that machine, human-wise. And yeah, and it's kind of crazy, but for them, a breach is, go out of business, that sort of fear to them. And so they could do that, whereas they can't assign someone to watch every single log entry from every single machine, because you imagine a company that already has the resources to even do it for one, has so many machines that it's just too much. But having that one central source in addition to that gives them that single source for auditing. Any secret access has to at some point go through that one machine. Especially if you have dynamic secrets, short leases, things like that, they have to come through that machine at some point. And so for any sort of fear of breach or any sort of actual breach, that's a great place to sort of start your forensics and start your search for what went wrong and where it went wrong. And then finally, for those security people, having that one source allows them to just configure one thing for policy. So when you have your secrets all over the place, it's hard to say you as an individual or you as an application could read this and write over here and do this. But when all your secrets are in one place, you have one way to write policy to access anything in there. You have one way to review the policies of anything that are in there. And again, sort of audit those policies of, is someone accessing too much or things like that. The single source just gives you a focus of where to be. So there are cons to the centralization. One of the cons is obviously that in our reference architecture of multiple regions, secret access has to communicate over the WAN, right? You have to communicate over maybe from the East Coast of the US out to Europe. And there's potentially a single point of failure. These are both things we've solved, but for better or worse for you, they're in Vault Enterprise. Vault Enterprise is our commercial product. It has two modes of replication. One is called performance replication, and one is DR, disaster recovery replication. Performance replication lets you run a vault in every region you want, and it's replicated some subset of the secrets. You're able to say, I only want this, or I only want these policies. And it's a sort of a, it's not just a cache. I mean, it handles some things on its own on some other servers, but it's not the whole vault. And then disaster recovery replication is an inaccessible, doesn't respond to API requests, is a more completely locked down replica of Vault that all Vault data transfers to. And so as an example of this, our largest current Vault Enterprise customer runs around 30 data centers, 30 totally geographically diverse data centers. All of them run a performance replica, and 3 of them have a disaster recovery replica. And so they could withstand 2 major all 30 will, well, 30 minus the 2 that failed will still be available. Yeah, I think that's all there is to say about them. So that's all sort of solved, but behind a paywall. And then on the run Vault securely sort of side of things, there's this page that I link up here. That page just has a bullet point list of things to think about. That's not going to be in-depth for this version of Linux or however this step-by-step how you set up a secure vault. That's sort of the notes for what you need to think about. And these are actually the things they talk about, but for each thing, there's sort of a paragraph of why and a bit about how. We have other guides that are more step-by-step for how to secure it in certain environments. As you might expect, depending on your operating system and your networking setup and various things, that's very dependent on the company. So we do our best. This is the most generic one. I'm going to go over each of these. There's a lot. What makes this nice, though, is that if you're already an expert operator, this isn't new, right? These are security best practices that you should apply to anything that you want to run securely. So you're not learning anything new about Vault. It's just run Vault as a highly privileged process. And again, the other thing in addition to this that helps is the threat model. So as an example, one of the things that is not covered by our threat model is arbitrary memory access. If things could read Vault's memory, then you're in trouble. The whole Vault should be considered compromised at that point. And that's why things like disabling swap are super important. Disabling swap, disabling core dumps, definitely making sure nobody has root access, and Vault itself doesn't run as root. Those are all extremely important things. So moving on to the more meaty thing, which is how this auth actually works. So Vault, first stepping back, has this ability to have auth methods. And so Vault and auth methods are different ways to authenticate to Vault. There's a number of different ways you could authenticate to Vault, and there's only one way that Vault does authorization. So the authorization comes from the Vault policies. That's the single language for authorization. But how you gain an identity that's a is completely pluggable. And the reason for this is because Vault is trying to be your central secrets solution, and two very different kinds of things need access to secrets, and that is people and applications, right? The way people prove their identity is just different than the way a machine proves its identity. So people will use things like OAuth or a username password or an Active Directory to sort of prove their identity, whereas a machine will use tokens or a hardware module or TLS certificates, you know, to prove their identity. Both are very hostile to the other, right? Like a human type in all their prime numbers to prove themselves is not going to work. Whereas having an application go through a web flow to OAuth is not going to work. So auth methods are a way to solve both of them. And you could also write policies against certain auth methods. So you could say that if you logged in through GitHub, you can only read these keys, but you can't write anything. It's just we don't trust your GitHub security enough to do it. But if you logged in through a TLS client certificate, you could also write. But you're the same person, right? You could actually restrict policies by auth method. And as part of the auth methods, there's this thing called the platform native auth method. And this is authentication using some platform-specific identity. So the main thing here for security people, security always ends, no matter what, it ends at some point where you trust something. You have to have trust somewhere, and for some people, trust is very high. It's very easy to trust anything, and for some people, trust is very, very hard. To use this, the level of trust that we require or Vault requires is that you have to trust your platform. So if you're on AWS, you have to trust that Amazon themselves are not malicious. If you're running Kubernetes, you have to trust that you operating Kubernetes, or if you're running a service of Kubernetes, that they are not malicious to access the things inside of it. That's the trust that's necessary here. If you don't trust that, we have other ways to authenticate, but they're much, much more filled with friction. They're a lot harder to set up, and they require a lot more work on your side of implementation. But if you do have that trust, we allow sort of that platform to provide the identity that Vault will verify. So to use AWS as an example, this is how the EC2 authentication method works for AWS. There's two ways, and this is called the EC2 method. And I'll walk you through it. So if you have a set of EC2 instances starting down here, you start with an EC2 instance. Step one, it hits the metadata service. So Amazon puts a metadata service at a fixed IP on every EC2 instance. It can't be disabled. It can only be firewalled off with IP tables. So it's always there. That EC2 metadata, as part of one of its hundreds of paths, contains a signed document that has a bunch of identity information about that specific instance. So you grab that document, you send it to Vault, and when you talk to Vault, you're saying, here's this signed identity document that I claim is me. I'm saying this is me. Vault can't take your word for it. So what Vault then does is talks to Amazon. Amazon publishes all the public keys that it uses to sign those documents. They vary by region and service and all that sort of stuff. Vault knows how to find the right public key for your document. It brings it back down, verifies the signature, and it uses that as a base level of trust that you are the right thing. And then it goes further, goes back to the EC2 API, takes the decrypted metadata, and it says, well, you say that your instance ID this, and you're in VPC this, and all this sort of things. And it actually queries EC2 and says, do you actually have an instance here that's in this VPC that was launched with this AMI? And if all that, and importantly, is still running, and if all of that matches, then finally at the end you get a token back, right? And this and all the other platform native flows are great because if you trust the cloud platform, this could all happen without a human in the loop. So if you're using Terraform, or if you're doing it manually and you're just starting an instance and Chef or Puppet is running or something, all of this could just happen through automation. So in that ephemeral case where servers are coming and going, without human interaction, you could still authenticate. So that is the reference architecture. That's how it works. Now I want to actually do it to show you how easy it is. And I mean actually do it. I'm going to tab out. I'm going to put a terminal up there and do it. And so the plan is to do this, where this is my laptop right here, and then have two regions. I'm actually not going to do the AWS one for time, but it'll apply equally. But I showed you how AWS works, so I'm actually going to use GCP and show you how GCP works to show you a second one. I'm going to spin up a GCP region. I'm going to set up AWS auth, and then I'm going to have those servers auth with my laptop and access some secret information that I'm going to write on my laptop in front of you. That's the plan. The warning is that none of this is production how you should do it, right? Like from the obvious thing of I'm running Vault on my laptop to the various steps I'm going to skip. The thing that what I'm going to show you is going to totally skip is how to run Vault securely. I'm going to do the complete opposite, which is how to run Vault in all the wrong ways possible, but in a way that'll show you this quickly. So starting with running it in the dev server mode, which is basically throw away all security for convenience. So, but it'll work. So let me switch to mirroring my screens. Great. Okay, so I'll zoom in. Never fear. We'll need one more. Okay, so let's start the dev server. So it's a little bit hard to read, but what the dev server does when you run it is that it pre-configures a bunch of stuff so you don't have to provide any configuration. So it runs with all storage and memory. It doesn't put anything on disk. It already unsealed the thing. It configures Vault with only one unseal key, which is super insecure. It's not running TLS, so everything is not over TLS. So that's how everything will be. But in a production environment, everything would be over TLS, so we lose the encryption in transit. And I think that's pretty much what it does. And it obviously drops you like the unsealed key and the root token right in your shell, which is not what Vault would ever do. The actual bootstrapping process of Vault supports modes where we could verify that no one in the middle could see them. So this is all insecure. So that's running. Just get that over here. I need this token. And then the next thing we're going to do is actually visit the UI. So the UI in dev mode is on by default, and like I said, it's built into the binary, so you just got to visit your Vault address and it redirects you to the UI. It knows you're coming from a browser and things like that. So this is the UI of Vault. In a production mode, you have to opt in to running the UI, but that's just one line of configuration. There's a bunch of ways you could log in here, but I have a token. It's on my clipboard. This is probably going to disappear real soon, but the UI itself has to think about security. So normally when you give it a token or auth, it'll like any website sort of remember you. It'll store that in local storage so that you could go back and access things. But it knows that I just put in a root token, which is horrible in itself, but it won't store it. So if I refresh the page, I actually have to re-auth. And this is the UI. So this is one of the new things in Vault 0.10. It provides a way to access secrets and do a bunch of cool stuff, including a bunch of cool tools. Like do you need random bytes? Like you could use Vault's entropy to actually get random bytes. Do you need to hash something? You could do that. Wrapping and unwrapping is a way to wrap data in a way that can only be decrypted once. So it's a way for you to wrap it and then send it to somebody and verify that only they actually read it. So if you want, if someone across the room is like, hey, what are the IAM credentials we're using for dev? Instead of just like throwing it in Slack, if you both have access to a Vault UI, wrap the data and then they can unwrap it. So there's a bunch of neat tools that just exist that aren't production like useful, but they are useful for teams. But what I'm going to do next, I actually don't know. Let's see. Oh yeah, we're going to set up Vault. So to set up Vault, I'm first going to create the secret that we want to protect. And then I'm going to create a policy that only accesses that secret, and that's the policy I'm going to apply to the machines that are authenticating. So they're not going to get root access. So let's first create the policy, because that's here. This is showing you how to do it from the CLI. I'm going to do it from the UI, because it's easier. So you can manage policies from the UI. Name it reader. And so this policy is pretty straightforward. This is the path of the data. You could just read it. I think that's pretty straightforward. Capabilities is read, save it. So yeah, now we have the reader policy and it's there. So we created the policy. Yes, let's write a secret. So I'll use the CLI for this. You could totally do it from the UI, but I want to show you how the UI and the CLI. I mean, the UI is just built on top of the API, so I could do things from the API, the CLI, wherever, and it'll all match. So I'll start here and do, I think it's hug. Let's just do Paris. So I created it. This is a version secret, so it's version 1. If I go back to the UI and go back to secrets and go to secret, you could see hug, and you could see locations Paris. I could easily create another secret here, but I don't need to. Yeah, so all that stuff sort of matches. So at this point, we have the vault set up for the data that we're protecting, and now I want to set up GCP to be able to access it. So let's go over how GCP auth works. Let me full screen that. How GCP auth works is similar to the AWS one, but really quickly, very similar. You start a GCP instance. It has a metadata server as well, just like AWS, but it has a slightly different format, so you have to curl it and send some data to it, and what it returns to you is a signed JWT, a JSON web token, for the data you sent in. You take that JWT, you don't need to decrypt it or anything, you take that JWT back to Vault. Vault talks to Google, gets the right public key, decrypts JWT, and does the same sort of thing. Verifies that the JWT is legit that way. It also queries Google to verify your instance exists, you're in the right region, things like that. And then you get a token back at the end if you're correct. So this is how GCP auth works, and similarly, if you were to use Azure, it's quite similar to this, except you're using Active Directory as the identity. So let's not do that. Let's start by enabling GCP. So if we go to access, we can enable a new auth method. You can see that there's a bunch that the UI supports, and I think there's over 20 auth methods, so there's a bunch that the UI doesn't support. But if we go to Google Cloud, it needs credentials. That's over here. I think I'm logged in still. So I created a project for this. Yeah. Create a key. 0f. 0f. Yeah, so upload the credentials. Okay, so the GCP auth is enabled, but nothing could actually authenticate yet, because what we have to do is create this thing called a role. So within the GCP auth, a role is basically a type of server that can authenticate, a bunch of restrictions to that server, and what policies it would get. So what this is saying is that we want a role named web. That's arbitrary. You can type anything you want. It's going to be coming. There's multiple ways to do GCP auth. Ours is going to be GCE, which is the flow I just showed you. There's other ways to support non-compute instances, to support like functions as a service and things like that. But we're going to use GCE. When it auths, it's going to get the reader policy that we created, restrict it to this project ID. So the call has to come from this project ID. And I'm actually going to add more to restrict it by availability zone too. So I'll show you that. So I'll copy this to start though. And this for now, the UI does not support setting this up. So we do have to do this from the CLI for now, but it's on the list. Yeah, don't worry about my shell. It's unwell. So I'm also going to bind the zone. So the zone, I actually don't remember what they're called. So let's just go start some things. Yeah, let's pick like US West 4A. So if we bind the zone to Europe West 4A, yeah. So this is saying that only instances in this zone could actually auth, right? And you could bind the image IDs and all sorts of stuff, and they're all additive. So more bindings will restrict things further. So I'm going to create a server. Let's start some instances there. I'm going to just use Ubuntu because that's what I practiced on. So I don't want to. We'll create that. Let's create another one that is not in the right instance. Let's do Europe West 3B. Do Ubuntu again. Create it. So that those are just starting to go, although it's pretty fast. Yeah, and then the next step is just going to be starting to authenticate. So at this point we've configured everything that we need to configure, and now we're actually going to auth. So let's start with the one that should work. That's in the Europe West 4 region. Do that. SSH into it via the web browser. While that's going, let me just copy this. Oh, I got to run. How is Vault ever going to be accessed? Great. You could visit that if you want. I mean, it'll be my Vault running. I doubt you memorized my root token, so. Okay. And this should be pretty quick. This is usually pretty fast. So we'll SSH into the machine. We'll do the auth, and this auth should actually work. It's not true. Okay, so let's, we need to export the Vault address. This is the address of that it would actually be running, so obviously I can't access that from here. I can't really scroll up, so I could do this. That's the address. You just need to set it for the signature. So let's do this. So in this, let me run this first and then scroll down. So this one, we're getting the JWT. This is the right way to curl the metadata endpoint with things, and then and we're saying we want the web role. So this has to match the role that you created as part of the JWT. We could see it. It's just a bunch of garbage. So now you have that thing. That's what we want to send to Vault. So, oh yeah, the slides use the Vault CLI. I didn't install Vault or anything, so I'm just going to curl it, and that should work fine. Nope. 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 I'm going to actually install this so you could see the output better. So like I said, don't worry about me just sudoing with no password and all this stuff. It's fine. Okay, so need this. And this is super annoying because I need to reference a variable. Yeah, so this should work. Let me run it, I guess. It'll pop out to the top, I think. Well, yeah. Well, we're on a web shell, so you kind of lost some stuff. But it worked. So this is actually the response that we got from Vault. That's a real token that can now work with Vault. We've authenticated. It told us the policies we have. And one of the neat things is you get a bunch of metadata too. So this is stored both in Vault and in the audit logs and things like that. So when we audit requests from this token, we include the metadata. So if that itself isn't clear, which it shouldn't be clear to any non-robot person, you could actually see the instance ID, that it was a GCP thing, the project it was in, and various other stuff about it. So that's just stored with it. If we take this token now and we curl our secret data hug. I think this is what it is. Then we should also get the secret back. Yeah. So we curled it, we used the thing, and we could actually access the secret, right? It says location Paris. And just to prove it, if I change the token to one that's not right, we get permission denied. And so one of the other neat things from the UI is that you could actually see the leases that are currently out. So auth generates a lease. Again, same thing. You don't own that token we just gave you. Vault owns that token. You just have a lease to use it. This is the ID from it. This is what would show up in audit logs. So if you needed to search it, this is the way you would search it. But if I look at that, we don't show the metadata in here yet, although we will eventually show the metadata in here. But you can see that this lease was just issued. It's still renewable. It expires at a certain point here, but if that's not friendly enough for you, a month. and some other stuff. But one of the fun things about it is I could actually come over here and just revoke it. Be like, you're done. Delete the lease. And then if I come back over here and use the correct one, the 6, not the 7, then even that now is going to get a permission denied, right? Its access was revoked. So that's all cool. Let's go to the other one. Let's go to this one. So this is the instance that's in the wrong availability zone. And you probably trust me that it won't work, but I'll just show you that it won't work and you get a nicer error message about it. Make sure I didn't skip anything. Nope. Okay, so we got to do all the same stuff again, but I'll do it quicker. Yep, I got to do all this again. So I ran it, and you can see I get an error message back that it's not in the right zone. It won't tell you the right zone because that'd be leaking a bit too much, but at least tells you that the reason your auth failed is that you're not in the right place. But I could easily sort of come back here and let me delete that, and then what zone is it in? Wait, it was in 3B. I could rewrite the data, their configuration, and this should work now. Yeah, so now I was able to authenticate correctly. I think I could have just, I didn't have to delete it. I could have just overwrote it, but I don't know. I didn't practice that, so that was just kind of winging it. So that's pretty much all there is to it. I mean, it's pretty straightforward. And then, the next step obviously would be to do AWS. It would look very similar, so, and for time, I'm not going to all over again, but it looks just like that. You would turn on the AWS auth. You would configure a role. This looks similar again, but you could bind different things, obviously, with AWS, like the VPC ID. You then log in. Getting the thing, the JWT equivalent for AWS is a lot easier. You just curl something directly into it, so it's actually a lot easier. There it is. And that's pretty much it for AWS. And then there's more you could do. So there's Azure, which is similar. And then there's Kubernetes, which is a little bit different, right? Because it's not a cloud platform, but is actually feels the exact same. With Kubernetes, you don't need to install any plugins to Kubernetes or anything. Kubernetes launches every pod with, I think it's called a service identifier or something. But it uses that same concept of you just configure the Kubernetes auth properly. You get that service identifier. You hit the right Vault endpoint, and Vault will give you a token, or it won't. We don't mess with Vault Kubernetes secret engine or anything. You could use that if you want. You could totally ignore that if you want. The Vault auth is completely separate from that. So we have that, and we're always building sort of more of these. And I think that's all there is to it. So thank you, and I hope how not hard that could be. Like, I went from nothing to starting Vault and configuring it and starting an instance and logging in sort of in, let's say, 10 minutes max. And all you would have to do that right is just in a more production-ready way, which is just operational locking down. It's not, the process itself is very easy. So thank you, and we'll do Q&A. So there's a microphone, if anyone has any questions. There's one in the middle.
Hello. My question was more about what's ideal purpose of Vault for you, meaning that it is supposed to work as a centralized thing, meaning that you intended for deploying secrets that will be used several times in order, for instance, to request a database or something like that. But I also see that you are you have the one-time secret stuff, and when thinking about one-time secret stuff, I'm thinking also about scalability. For instance, if it's a single instance, you might run out of entropy or something like that, for instance.
Mm-hmm.
So how did you think the product regarding this? Is it intended for very high throughput, or it's just for one-time secrets, bootstrap issue?
You could use it for both. Obviously, at a certain scale, you do have to worry about running out of entropy. So there's various ways to solve that. Some types of backends allow you to bring your own key. There's obviously security concerns there, but some things allow you to bring your own key so that you don't waste Vault server entropy. Other things are, Vault Enterprise performance replication. Actually, we could trust the other Vault nodes, so we will share entropy across the systems. We could generate entropy on the other machines. But realistically, I think for a big enough Vault deployment, we've never heard of a high scale enough usage where people run out of entropy, because usually your sort of compute load and various other load factors require you to start doing key offloading and things like that. So to give you an example, the encryption as a service sort of thing, one of the big cons to encryption as a service is that everything that needs to be encrypted needs to go through Vault. So Vault theoretically would need to be able to service the sum total of all the throughput of your entire system, which is not realistic. So we have a very large Vault user. It's a very large chat network that encrypts every single message in chat with Vault. It wouldn't work. And so what they do is they take on the load of some security, which Vault calls exportable keys. Vault generates the key, but then gives it off to a side process. And it does all the encryption on the side process. But you need to be careful, obviously, about the side process. So there's various escape hatches that Vault gives you at high scale at the expense of increased burden to integrate. So you could do it for anything, but I guess the answer is it depends. Yeah. Yep.
Thanks for the presentation. I got a couple of questions. The first one is regarding the CLI. So in the versions, I think 0.8, 0.9, for example, the mounts and the secrets have changed. So do you have a roadmap for solid like CLI that doesn't change, or can be different in the upcoming versions?
Yeah, so we've only changed the CLI once, really, right? But it was a big change. We don't really want to do that again, and we weren't super happy with the way we did it. It was just like one day it was totally different. So we just don't have any intention to ever do that again. If we do CLI changes, we'll be a little more backwards compatible with them. Like, for example, we introduced version KV in this one. If you were scripting Vault with the expectation of non-version KV, all the workflows are the same. It just assumes latest version, which is probably the same. But we also support new flags. So we tried to introduce it in a backwards compatible way. Yeah.
And my second question, now you have a new designer, I think, for the user interface.
Mm-hmm.
So are you planning to change the design of Vault or console in general, or you're sticking with the same user interface?
Yeah, so this is now sort of the design of our interfaces. So the other thing that currently has a design like this is Nomad. Like, Nomad looks exactly like this, except the header is green and it has a Nomad logo. Fonts are the same. The layout elements are the same. So we're doing component sharing between all of them. Console has completed a redesign and is currently in user and customer testing. So Console's UI will very shortly look like this. And sort of related to your CLI question, we don't want to introduce a new UI and suddenly everything's different when people are used to doing the right thing. So the way we're introducing the new UI in Console is it'll be behind an opt-in flag at first with the old UI still the default. And then we're going to put a banner that's warning people. And then it's going to switch to the default but allow the old UI to go behind a different flag. So you could still access the old UI for some more months. And then finally, towards the later part of this year, we're just going to delete the old UI completely, but move its code out to a separate repo. So if you still wanted to build that UI and run it separately from the console binary, you could, but it will no longer have bug fixes. So that rollout will happen, but this is what they're all going to look like.
So I
going
take
forward.
advantage of the question. So does console will look like Vault, the user interface, or it's going to be completely different?
No, it looks like this. It just has a pink header and a console
right.
C. Yeah.
Thanks.
Any other questions?
If I'm not mistaken, as of today, all secrets are tied to the token itself.
Mm-hmm.
Is it planned to be able to tie them to the entity instead of the token?
Yeah, definitely. So, yeah, I mean, yes. The answer is just yes. So the all the entity stuff is relatively new to Vault. All the identity logical grouping that came in towards the end of last year. So it's still relatively new, and we're still just continuing to build on the entity system. It's quite tricky with Vault just because due to the way Vault runs like in the data path for secrets, we can never break API compatibility, basically. So we're trying to figure out how to make these shifts without having people to rewrite integrations. And that was the hard part with introducing entities too, since the identity was just a token before. Yep.
Hi. Thank you for the presentation. My question is about staging the configuration on the secrets. What are the recommendations you have at HashiCorp?
Can you speak up a little bit? Sorry, I can't hear.
My question is about staging the secrets for pre-production systems, testing the secrets and the deployment of the secrets on a pre-production system, and then deploy it in a production system. What are your recommendations on your experience?
Yeah, so there's a few ways people do staging secrets across different stages. Most commonly, people run different Vault clusters, and they just rerun the sort of the API calls onto the production. That's a very safe way to do it because you never risk doing things to production, doing things to like staging that affect production. There's also other ways people have wanted to do this, either via sort of different mount like paths. They'll mount the same like secret backend, but one will be /dev secret, one will be /prod secret, and then you just have to change the prefix for all API calls and you'll get the new thing. And then also Vault later this year will also support namespaces and multi-tenancy. So you could just have Vault look like a different Vault, but it's actually just a different namespace. People want to use it for that with the understood security concerns. The use case more for that is less stages and more teams, right? Like you want a central team to be able to define policy and mounts and stuff, but you want each app team to be able to write secrets to /secret, but it to be their own team thing. So each team will get a different namespace. So that's really the use case, but it could be used for that. All right. Okay, so we're going to do the drawing now before we eat.
Est-ce que tout le monde a participé? Non, vous n'avez pas participé. Vous avez encore... allez, vous laissez remplir rapidement votre nom, prénom. Et puis après, Michel va faire le tirage au sort.
Okay, is this for the HashiDays ticket?
So I don't really know how many... What exactly do we have? Okay, so this is for the tickets. We are just waiting for the 5 people that want to participate.
And remember, this is HashiDays in Europe, so it's not far away. Yeah, Amsterdam. Actually.
Il n'y a pas d'autres questions du coup? Il y en a qui auraient pris le temps de réfléchir à quelques questions. Non.
That all of them?
Excuse me.
Oh, sorry.
I just want to know if there is many use case in documentation.
Is there what in the documentation?
Vault is quite new, so Vault is new, and many people don't know how to use it. And I think there will, my question is there will be many use case documentation.
Yeah.
How to use it, and
Yeah.
because we don't really know, and people are not confident about Vault.
Okay. Yeah, so the question I think is, correct me if I'm wrong, the question is about what kind of documentation do we have to help new users? Are we writing more documentation about these new features? Do we have guides about how to set up Vault, things like that? Is that right? So Vault has great reference documentation, but that's like being given an encyclopedia. It has a decent getting started guide, and then it has sort of okay set of guides. But the last section, the guides or the step-by-step guides, we actually just, starting at the end of last year, now have a couple people full-time just writing guides. So there's basically a new guide nowadays every week. Like last week, we published a guide of how to run HA Vault with console, and that's not a bullet point list. That's a step-by-step how you run Vault in high availability with console. And there's now an 8-page guide on how to operationalize Vault securely. So how to deploy it, how to set up replication, how to set up your system, things like that. So there's more and more every single week. So I would just keep an eye on it. They're all in English though. So yeah. Cool. Okay. This ready? Okay. You mix it. It's good. All right. This person. Romaine Marsclef? You? Okay. Congratulations.
Félicitations.